Hello and welcome. In this video, we'll be solving calculus questions, and without any waste of time, let's get straight into it. So if you are new to this channel, please hit the like and subscribe button just to show support to the family, right? So let's continue. So question 11. The graph of f of x, we have the graph of f of x there, and the equation is incomplete, right? So you can see, but usually these cubic function, it's x3 plus bx squared plus cx plus d, right? So you can see that here the coefficients were a little bit like swapped, because the a here, it's -1, right? However, what we looking for as b, what we're looking at as b is actually the a, and what we know as c is the b, and what we know as d is c, right? So yes, okay. And what you guys know about the constant, so I can just erase this part here. So what you guys know about the constant, so this we don't know, the b we also don't know, the a we don't know. So the c is usually our y-intercept, so the last coefficient that does not have a variable next to it is our y-intercept. So the y-intercept is this one here, where x is equal to 0, right? So now the x-intercepts are indicated, right? So we can see that we've got x1, x2, and x3, right? So let's get straight into the first question. Calculate the values of a, b, and c, right? So 11.1, y is equal to, we're going to use this formula, y is equal to x minus x1, x minus x2, and x minus x3. Right, so we can see that the a value here is negative. The first coefficient of which is the coefficient of x cubed, it's -1. And so this tells us that the shape of the graph here, it's gonna be smiley face first and the front face after, right? Like the way it's drawn there. And if a is positive, we're just gonna have a front face first and the sad face and the smiley face after, right? So we can proceed with this, right? And taking a look at this, the a value, the a value, we had it, right, which was -1, which is the first coefficient. So the first coefficient, it is my a value on this formula, right? Not the a value that they're looking for here, right? So we're gonna look for that a value, which is known as our b value, according to the way we know the standard form. So x minus 1, so x1, first x-intercept is x1, the second x-intercept is x2, the third x-intercept is -4. Sorry, it's 4, so I'm just gonna put -4, right? So y is equal to -1, and then now we can just enjoy a multiplication between the two brackets. So you can multiply the last two brackets here. So I think you will see that we'll get x squared minus 4x minus 2x and plus 8, right? So y is equal to -1. So we can first simplify the second bracket. So it's going to be x squared minus 6x plus 8. So y is equal to -1. So now we can multiply these, the smaller bracket and the bigger bracket. So it's going to be x to the power of 3. And then the next one, it's going to be minus 6x squared, followed by the plus 8x. Yes. And now we can move on to the second term doing the same. So basically what I was doing here was the first term multiplying the first, and this multiplying that, and that again multiplying the last one, right? So now we can have the second term doing the very same thing, and it's simply just going to change the signs of all the terms of the second bracket, right? So the first one is going to be minus x squared when I multiply. The second one is going to be plus 6x, and the last one is going to be minus 8, right? So we can quickly add on the like terms quickly, which we will have minus that, and if we highlight the like terms here, see that is this one goes with this one, and this one over here goes with that one, right? So I hope you guys can see what we're trying to do here. And now you will see that we'll get x3, and this one will be negative 7x, those like terms, negative 7x squared, and this one will give us positive 14x minus 8. So now if we can multiply what the negative now is, simply going to change the signs of the terms inside, and now we'll have negative x cubed, positive 7x squared minus 14x with the positive 8. So now we have gotten the equation of the graph, right? So this is like someone asking you to find the equation of the graph when you are given 3 x-intercepts. So just remember that you have to say x minus x1, x minus x2, x minus x3, right? And you've gotten the values here. The a value is negative. Our a value is negative, but their a value is 7, and their b value, it's negative 14, and their c value is 8. Let's move on. 11.2. Calculate the coordinates of a and b, right? A and b are simply the coordinates of the turning points, right? So you can see that we've got a turning point which is at minimum, and the turning point which is at maximum. So this one, minimum, maximum. So if someone asks you the minimum, maximum, we know that we'll be looking for the turning points, right? And also stationary points, right? It's the same thing that we have to do here. Stationary points, right? So the first thing that we do in that, we have to take the equation of the graph. So we literally take the equation of the graph, minus 14x plus x, and then we get the first derivative, which is going to be minus, so the equation of the graph, it's x3, so it's going to be minus 3x squared, because when you do that, when you do the power rule, you take this number, you multiply the coefficient, and you minus 1 from your exponent. You take the exponent, multiply with the coefficient, and minus 1 from the exponent, right? So if I do the very same thing here, I take the 2 and then I multiply with the 7, I'll get plus 14x, and then when I minus 1, I will get 2 minus 1, which is going to be 1, right? So there's like invisible 1 there that I'm not going to write, and then the derivative of this one with just x is going to be minus 14. You just simply write the coefficient. So what we're going to do here is to take the first derivative and equate it to 0. So we took the first derivative, we equated to 0, and now we can solve for x. Looking at this, this is just a quadratic equation, and I think quadratic equations, we've solved many of these equations. We just divide by minus 1 everywhere, right? We just want to make the a value positive, right? And this is 0, 3x squared minus 14x and plus 14. So let's use the quadratic formula here. X is equal to minus b over 2a, the square root of b squared minus 4ac all over 2a. So the x here, it's going to be minus negative 14, plus minus the square root of negative 14 squared minus 4, 3 and 14 all over 2a. So the x coordinate, one of the x coordinates, it's going to be 1,45, or the other one, it's going to be 3,22. So the question was asking for the x coordinates of those turning points, and I think if we're looking for the y coordinates, we would have taken these answers and substitute them into the original equation, not the derived equation, but the original one, the one that we got, which is this one. So you can substitute these x's here into this equation, you will get the y, the corresponding y values. So I think you can clearly see that here, one of the coordinates, it's 1,45, which is in between that, and the other x coordinate, it's here, which is 3,22. Right? So the last question, 11.3, it's asking f prime x less than 0. So this one, it's asking where the graph, so values of x, they're looking for values of x where the graph of f of x, if it's less than 0, it's looking for where the graph of f of x decreasing, right? Meaning that if it was the f prime greater than 0, we will be looking at the increasing part, where the graph is increasing, right? So where is the graph decreasing? And I think the CVs for increasing, decreasing, so the CVs are x values of turning point. So once you know what are the x values of the turning points, you can look at the x values of the turning points, right? And the solution is somewhere there, right? So let's go and take a look at this graph. We'll read the graph from the left, right? And if you look at the graph from the left, going to the right, as we move this way, you can see that the graph is actually decreasing. So the graph is decreasing until the turning point. So the graph is decreasing, and from the turning point to the turning point, the graph is increasing. So you can see the part in green there. I'm indicating increasing, the graph is increasing there. And this other side, the graph is also decreasing, right? Because we read it from the left going to the right. So if I was saying, write me the values of x where the graph is decreasing, the graph is going to be decreasing less than negative, less than the x value, is less than this value, or it's greater than the other x value of the turning point. So this part here, it's where the graph, it's decreasing. So this is the interval where the graph is decreasing. So let's go and take a look at where the graph is increasing, which would have been the prime greater than 0 for increasing. Where's the graph increasing? The graph is increasing in between the two x-intercepts, so the two x values of the turning points, which is minus 1,5 and 3,22. So I know that this is a bit extra. They were looking for just the decreasing part, if you pay attention to the question. So if you pay attention to the question, they were looking for the decreasing part. And where is the graph decreasing? When the x values are less than 1,45, or when the x values are greater than 3,22. So I think it's perfectly fine with that question. We've fully answered the questions, and I've given you some extra information looking at the increasing. So they're looking for where the graph is increasing, where the graph is decreasing if it's less than 0. But if it's greater than 0, they're looking for where it's increasing, right? So I think if you watch the video once again, you will understand that. So let's quickly move on to the second part of the problem here, which is another cubic function question here. So this one we have in question 9. So the graph of f of x, we have the standard form equation over there, which is for the cubic function, right? And we also given the one for a straight line graph. So these two are sketched, right? And a, we have the turning points coordinate -1 and 0, and we also have another turning points coordinates over there, and these are the x-intercepts of the graph of f, right? And the graph of f has got a turning point at a and another turning point at b. So it means that here the graph is turning on the line, which is the x-axis, right? And then here the turning point is turning somewhere, which is on the line, and the d coordinate is being shared by the two graphs, right? This is y-intercept of both the graphs, right? And I said if you see that the d's coordinate it's given, it means that this d can also correspond to this d. So the d's coordinate here, it's the y-intercept. So whatever y-intercept is, that one should be the value of the y-intercept. So it's -6, right? So E and D are intersection point. So this one and that one are intersection points of the graphs, right? So let's move on to this first question. Show that A is equal to 2, B is equal to -2, C is equal to -10, and D is equal to -6, right? So we'll say here, we'll take a look at this the thing. What are we given? So we're given x-intercepts. Because we're given x-intercepts, we can use this formula, x minus x1, x minus x2. So because there's two x-intercepts here, it means that we'll look at the diagram and see where the line is turning, where the graph is turning. The graph is turning on the line, which is the x-axis at A, right? So specifically, we're going to square that bracket where we will substitute the one that is turning on the line. So here 9.1, y is equal to a x minus x1 squared plus, sorry about that, it's not plus, it's going to be what? X minus x2, then we're not going to square the other one. So the reason we're squaring here is because the x-intercept here is at the same time the turning point, right? So y, do we have the a value here? The a value is the first coefficient, like I said, but we do not have it. We're not going to write the a value because we don't have it, we don't know it. But we can say x here and substitute the first x-intercept, which is -1. So here I will say minus -1, and then I square this, and then here we say x minus the second x-intercept, which is 3, right? So we'll have y is equal to a x plus 1. So if the x-intercept is minus, you substitute it as negative, you will see that it will multiply, the two would multiply and give us positive. So x minus 3. And then here we have a coordinate pair that we can use because we don't have the value of a. They will give us a coordinate pair, 0 and -6. So when we substitute this, we will see that this will be -6 a, 0 plus 1 squared, 0 minus 3, and the answers here will get -3. If you simplify this, you'll get -3a and -6. So if you divide both sides by -3, we'll see that the a value would be 2. So we've gotten that the a value is 2. We've solved that. And now to get the other ones, we can substitute back our a value into this equation over here. And substitute it into this equation over here. This one. So let's substitute our a value there. Our a value is 2. So here we've got x plus 1 squared and x minus 3. So how do we deal with this? We can deal with the square bracket square bracket, we're just gonna open x plus 1, x plus 1, x minus 3. So y is equal to 2. X times x is x squared plus x. So we're just foiling the two brackets, which is this and that one. So x plus 1, and then x minus 2, x minus 3. So after the x minus 3 here, we can simplify this. 2x squared plus 2x plus 1 with the x minus 3. And now we can multiply the brackets. So we'll get x to the power of 3, x to the power of 3, and then we will get x to the power of 3 minus 3x squared minus 3x squared, and then plus 2x squared. So this is a square, by the way, sorry. So minus 3x squared plus 2x squared and minus 6x. And then 1, we can also multiply 1 plus x and minus 3. So I hope we did everything correctly here, and if that's the case, then we will see that this will get x3, and we will get x squared here when we simplify. So on the other one we'll get minus 5x and minus 3 on the last one. So now we can multiply with the 2. So you need to be a little bit careful with this, because once you make a mistake of the sign or any unnecessary mistake, you will lose marks because you will not be able to get your values, right? So we can see that the a value there, it's going to multiply inside here, and then we will get that, and then we'll get minus 10x, and we'll get minus 6. And I think it worked perfectly fine there. The values of a, the value of a is 2, the value of b is minus 2, the value of c is minus 10, the value of d, it's minus 6. So if we do everything correctly, we'll get the right answer. And I think it's not that long. I mean, if you do this, you can, if you follow every single step that is necessary, you will get your answers, right? So I think I will just quickly erase this just to have space. So if you don't mind, you can take a screenshot quickly for this part, right? So I will just erase this. So we have gotten the equation of the graph, and for the next question, they are looking for the turning point's coordinate. So calculate the turning point's coordinate. So there's a difference between a question asking x coordinates of the turning point and the question asking coordinates of the turning point. So 9.2, quickly this question, y is equal to 2x cubed minus 2x squared minus 10x and minus 6. So here we have the equation of the graph. They're looking for the turning point's coordinates. We have them, the coordinates, the other one is here and the other one is here. So let's look for the x-intercept of these coordinates. So 9.2, the y is equal to the y prime, we get the first derivative, 6x squared minus 4x. We're just multiplying this, we're just deriving this, and we'll get minus 10. So this, we can take it and we make the prime to be equal to 0, and then solve for x. So this is 0, 6x squared minus 4x minus 10. We can divide by 2. I think 2 would go into any of these numbers, and 0. So this is going to give us 3x squared minus 2x minus 5. So once we get that, we can use the quadratic formula. So I like to advise students to use the quadratic formula. But should you use the quadratic formula and you will see that one of your x values here is going to be 5 over 3, and the other x coordinate here, when you use the quadratic formula, you're going to get -1, right? So I think you can just reverse these factors. You know that these x equal to 5 over 3 came from 3x. So it came from the 3x. So it does 5 over 3. If you can cross multiply this was like 3x equal to 5. And if we transpose the 5 that side, this was 3x minus 5. So I know that this is not an appropriate way of teaching people how to factorize, but you might as well just do it, just to allow yourself to have those factors and sub them back into the formula, right? If you can just reverse this one, it's x plus 1. So it's easy when it's one number, when it's not a fraction, when the thing is a whole number, because we can just especially when we have whole numbers or integers, right, we can just transpose them back. And then, but if it's a fraction, just remember that you cross multiply back and then you put it into the, just to earn yourself 1 mark for the factors, right? And I think that the coordinates here for the turning point, we will take this and substitute into the original formula. So we'll have 5 over 3 cubed minus 2, 5 over 3 squared minus 10, 5 over 3, then minus 6. So we'll get that the value here for this one, it's going to be minus 512 over 27. So we can also do the very same thing for the other one. We substitute the other x coordinate, 2 minus 1 cubed minus 2 minus 1 squared minus 5 minus 1 minus 6. If we do that, we will see that our a value, it's going to give us our y value is going to be 0, right? So what this tells us, it tells us that we've got two x-intercept. We've got two turning points of this graph, right? And one of these turning points is -1. And the other turning point here is 1,67, which is that 5 over 3. As a fraction is 5 over 3, but if we write it in decimal form, it gives you this, right? And I think you would have seen that your turning points coordinate, it's -1 and 0, which is this other coordinate here. It was there, but the question was looking for the b's coordinate, right, specifically. And if that's the case, you'll see that the b's coordinate here, it corresponds to 1.67, and you can also change this to the y value as a decimal, and I think you'll get 18,96 if you change it, right? I think that's perfectly fine with the 9.2, and we can quickly go to the 9.3 question. So if you don't mind, you can quickly take a screenshot of this and we can move on to the next question. So now let's move on. Let's quickly move on to the next one. So 9.3. So with the 9.3 here, I think it's another question that we need to take a look at. So they're saying that h of x, right? H of x is the vertical distance. So if it's associated with the vertical distance, and it's going to be between the two graphs, right? So there's going to be a top function somewhere and the bottom function somewhere, right? That is h of x, f of x minus g of x. So I think they've already done that for us, right? They've already indicated that the top function, because usually the top function is going to minus the bottom function, right? So let's look at what they're trying to do here. So the top one will minus the bottom one. But here, what exactly are we trying to do here? We need to calculate the x value such that h of x is at maximum, where x is less than 0. So where x is less than 0, this is where x is equal to 0. So if x is less than 0 is this portion, and x is greater than 0, it's the portion on the right. So they're saying that h of x is that vertical distance. So 9.3, h of x as a vertical distance. Vertical distance means that it looks more like this. So, but we've already indicated that it's on the left, right? So it's somewhere here. So the vertical distance, it's on the left. It could be any of this distances here. So we're looking for the distance to be at maximum. So no one can tell us exactly what is the x coordinate that corresponds to the vertical distance to be at maximum. Even if you take a ruler and you measure this, but you will still not know what is the x coordinate that corresponds to that, right? To that being maximum. So what we do here is we take the function, we take the functions, and we say h of x is equal to the top function. So we look at the graphs, we look at the portion, and the portion, I think it's on the left. So the top function, it's this one, the one in green, which is our f of x. So this thing, we will answer it using f of x minus g of x, because the top one is f of x, right? So I think here they've already done that for us, right? Meaning that they're saying the top function minus the bottom function, the one below the other one. So we'll take that, I'll take the top function, then I minus the bottom function. So now this is going to be in terms of equations, right? So f of x, what is the equation of f of x? We've already gotten the equation of f of x. It was 2x cubed minus 2x squared minus 10x minus 6, and then minus into 6x minus 6, right? So we'll just have to quickly do the simplification, right, for this, right? So they're asking for us to calculate the value of x for which that h of x is going to be at maximum. No one knows where exactly it's at maximum, but we know that it's that x coordinate is going to be negative because the difference of those two graphs are on the negative for that to be maximum. They're looking for it on the negative, right? So let's go and simplify this. We want to create an equation, right? And this equation, we will simply get its first derivative. So minus 6 minus, and then if you multiply this, that side multiply, you're going to get minus x and then plus 6, right? So if we try to simplify this, adding all the like terms, we'll get 2x cubed, and this one does not have a partner, so we don't have like terms for that one, but we do have like terms for this and that, and the answer is going to be minus 14 minus 16x is going to be minus 16x, right? So this ones can put then they will cancel, right? So we'll get that. So now to get the maximum, so for the maximum part or minimum, like I said, maximum, minimum, when you see the word maximum, minimum, something should be derived, but here we were supposed to first get the equation to derive, right? And if you get the first derivative here, you still follow the differentiation rules, and you will get that this is gonna be your equation. And then now you can equate this equation to 0. 6x squared minus 4x minus 16. So if we find the number to divide by, I think we can divide by 2 everywhere. Just to simplify this, we'll get that the answer here, it's going to be 3x squared minus 2x with the minus 8. And if we can factorize this, because it's factorizable, I think one of the x values on the quadratic formula, it's negative 4 over 3, and the other x value, it's 2. So if you can reverse this one, you act like you just reversed this coordinate, it's going to be x minus 2. You know that the x equal to 2 came from x minus 2. And if we see that one, x equal to minus 4 over 3, act like we are cross multiplying this. If you cross multiply, we'll get 3x equal to negative 4. And if you transpose back, it's going to be 3x plus 4. So you can complete your brackets here. So it's 3x plus 4. Then you earn yourself the 1 mark for the factors, right? And with the right answers from your quadratic formula, just if you can factorize, right? So I think now we got the 2x coordinates. So this 2x coordinates are x coordinates that are going to give us that at maximum, but the one that we're looking for is negative, right? So we will simply go and say this one it's not the one, right? And then we'll say therefore the x coordinate, it's minus 4 over 3 at maximum, right? But if they're looking for the maximum value of the h of x, we would have simply went on to substitute into the graph. So if they're looking for the maximum vertical distance, since no one knows the maximum vertical distance, the value, right, we would have just went on to the simplified equation, the one before we derive, and we can substitute. So if they were looking for the value of that, we would substitute into the simplified equation. Cubed minus 2 minus 4 over 3 squared with the minus 16 minus 4 over 3. So we take the x coordinate that we had here and we are substituting it into the original equation that was simplified, right? Not the derived one, but they're not looking for the value, and I think you would have done with the question here with your x equal to minus 4 over 3, but I'm just saying for next time you should take advantage, right? So we have another question here and we should quickly do it so that we know that we've covered all the 3 different cases, and especially for the cubic functions, right? We are given the function, right? And the function is defined by f of x, x cubed plus ax squared plus bx and the minus 2, right? So if you pay attention to this, you see that your y-intercept is given. Your y-intercept is given, and the x coordinate, where the x coordinate is equal to 0. So this is our x-intercept here. It's minus 2, the coordinate, right? So now we have that this thing, that the graph is sketched, right? And the p's coordinate is a turning point, right? So p and r are turning points, right? It's just that the other turning point of this graph is not given, but the p's turning points coordinates are there and they're given, right? So we are supposed to answer the questions, right? So the first question, it's saying that now let's show that the a value is 1 and the b value is minus 1. So if you take a look at it, we have an equation, right? So we have an equation here for the graph. So this is 9.1. So I'll just first copy down the equation of the graph. So we have the equation of the graph 9.1. F of x is equal to x3 plus ax squared plus bx minus 2. So this is the equation, and we have the equation is given over there. So if you take a look at what the information that we have on the graph here, we having the turning points coordinates, right, and the y-intercept. And by the looks of things, if we don't have like x-intercepts for us to think about the cases that we thought of previously, x minus x1, x minus x2, those cases, we only use these things when we've got x-intercept. So we're not going to use this, right? So what we can do here is to make use of the information that we have, right? So let's first look at the standard equation here. On the standard equation, we do have two variables, right? And when we have variables, we can think about to form equations, and so that we can solve these simultaneously, right? So on the original graph, I can substitute coordinate pairs. So we have -1 and -1 here. I can substitute the coordinate pair -1 and -1. So the y value is going to be -1, and then x coordinate. So this is x and y. So I put the y coordinate as -1, and then I substitute the x coordinate as -1 plus a -1 squared plus b -1 -2. So if you pay attention to this, you will have -1 this side, and if you put the brackets and put -1 and you cube it, you will see that the answer is going to be -1. And this side, if you square that inside the brackets, we will get that this is going to be +1. So I'm just going to write a here, and then here I will write negative b, because it will give us the negative answer. So the negative times the positive will get negative b, right, with the -2. Right, so we have one equation over here, right? And to simplify this, we can just do some necessary simplification, right? So we will have a plus b, so we'll have a minus b, and -1 -2. Punch on the calculator, -1 -2 on the calculator, you'll get -3, right? Transpose -3 to the right hand side, we'll get that -1 plus 3 is equal to a minus b. So this is one of the equations we have here, and it's equation number 2. So we'll say this is equation, sorry, the value is 2, but here this one you can say equation number 2. So the second equation, someone can say, okay, but because we do have a coordinate, which is the turning point, which is the y-intercept's coordinate here, -2 and 0, can't we just simply substitute this coordinate there? And so, and what we can do is, if we substitute this, I mean, it's just going to have everything here 0, and we'll be left with -2. So it's not gonna do much for us, or it's not gonna be able, we're not gonna be able to create an equation, right? So because this point that we are given here, it's specifically a turning point, and this thing you can only do it when the point that is given is a turning point. You can simply go and get your first derivative. So you can get your first derivative of this, right, of the equation. So you get it, and this one is going to be 2ax, right, plus bx, right, plus b. I think it's just going to be plus b because we are deriving with respect to x, right? So when we derive with respect to x, so the 3 is going to be 3x squared, and then this one is going to be plus 2ax, and this one, because it has only x, it's just going to be the coefficient plus b. We take this, we now going to say the x coordinate here, it's -1, but the derived coordinate, if you plug in a specific x coordinate, the output, it's the gradient. And because this point is a turning point, specifically at the turning point, the gradient is 0, right? So because the gradient is 0 here at the turning point, we are equating this to 0. We are equating the derived to 0. So we can substitute 0 here, saying what it means is that we're saying that the gradient at the turning point is 0, and for which the x coordinate that corresponds to that gradient 0, it is -1. So I'm plugging in the x coordinate as -1, and the y value, which is the derived, as 0, right? So we do this, and then now we can create another equation. So this is going to be 0, and if we punch this on the calculator, we'll get that we'll get the answer here to be 3. Answer is going to be 3, and plus, so it's going to be minus minus 2a plus b. And now we can create another equation here. How do we create another equation? We can take the 3. But here what we can do is we can make the other variable the subject of the formula, because we want to solve these two equations simultaneously, right? So I think we can just like transpose and make one variable. I think the easy variable to make the subject of the formula would have been b. So if we transpose this one, it's going to be 2a minus 3. So I'm transposing these two that side, and then therefore I'll say this is equation number 3. Then now I will sub 3 into 1. So if I substitute 3 into 1, my first coordinate, my first equation, it's going to be 2. So where I see b, I'm going to substitute the 2a minus 3. And then now we can simplify this. A minus 2a plus 3. And then here we'll have 2. A minus 2, it's going to be negative a plus 3. Then we can transpose this one that side. 2 minus 3 with the negative a here. I think it's going to give us minus 1, which is equal to minus a. And therefore now the a coordinate is going to be positive 1. So you can see that the a, yes, it's indeed negative. It's indeed positive 1. And how do we get the b value? We can substitute into the third equation. So you know simultaneous. You've solved a couple of problems with simultaneous, like many of these problems you've solved before. So therefore b is equal to 2. Then I plug in my a minus 3. So the b value here, it's going to be 2 minus 3, and it's minus 1. So now we've successfully showed that a is 1 and b is minus 1. Good. We can move on to the second question. 9.2. Hence, determine the x coordinate of r. I think it's still asking the same thing here over and over again, because we just simply gonna get the x coordinate of the turning point, and I think we just take the equation and we get the first derivative. So the equation here, the prime equation, the prime's equation is 3x squared plus 2ax plus b. So what we can do is we can plug in the a and the b value we got here on the prime's equation, 3x squared. Someone can literally plug them into the original, then derive that original, then equate to 0, and then solve for x, get to x values, right? So we can also still plug it into this one, x and minus 1. So f prime is 3x squared plus 2x minus 1. So now what we can do here is we can equate this to 0, because we're looking for x coordinate that correspond to the gradient as 0, which the formula automatically calculates the x intercept, so the x coordinate of the turning point. So now what's going to happen here is that we will get that the x coordinate here, I think this we can even factorize, if you don't mind. You'll get the x coordinate here, it's 1 over 3, which you know that this is 3x minus 1. Or the other x coordinate is what? It's going to be minus 1. And we know that here it's going to give us x plus 1 when we reverse it. So therefore the x coordinate, it's this one. And they're not looking for the coordinates of r for us to substitute into the equation, original equation, so that we can get the y. So 9.3, let's quickly do the question quickly. So 9.3, they're saying that write down the coordinates of the turning point if h is defined by, so now here we have like a new graph, right, which is h of x to f of x minus 4. So now I think this one would want us to have the equation, the coordinates. So if we're writing down the coordinates of this, we will need the y coordinate. But this is like you literally go to the y value of the coordinate of the turning point. So you literally go there and then you just substitute the coordinate, the y coordinate here at as f of x. So for example, because we have got one of the coordinates as -1, so here we'll have what? The x as -1, and the other one we're going to have 2 times the y value of that. So this is going to be -1. So you multiply that coordinate by 2, and then you also minus that 4. So it's going to be -6. So this is the new coordinate, right? This is one of the coordinates, right? So simply this one, it's going to be this coordinate transformed. So the -1 and -1 coordinate is being transformed, and now we don't know what this one is, but this one is 1/3 and some y coordinate here. The y coordinate of this, it's simply substituted into the original function, right? So we must get what the original function is. It's going to be 2x squared, 2x cubed, minus, what is the a value? The a value is +1. So this one is going to be plus x squared. And then the b value, we know the b value there, it's going to be -1. So this is going to be -1x, which is going to be -x. And we're also going to have the -2. This one is -2. So now to get the y coordinate of that before we can transform it, we must also plug in 1/3 here first, cubed plus 1/3 squared minus 1/3 minus 2, and the answer is going to be what's equal to -200 and no, not that, but we will have an answer. I think the answer is going to be 1/3 cubed plus 1/3. So we're first getting the coordinate before we can transform it. So plus 1/3 squared minus 1/3 minus 2. The answer is going to be -58/7. So this here, it is the y coordinate of the r, of the point r. So how do we get the other coordinate? The other coordinate, we got one coordinate here now. The other one, it's the x value is 1/3 and the y value is going to be 1/3, right? But now if we transform it, so the original one, it's 1/3 -58/27. So the transformed one, the x stays the same, but now we're just gonna say 2 times that y coordinate, 58/27 over 27, and then minus 4, and the final answer, it's going to be 1/3's coordinate with 2 times that minus 4. You're going to get -226/27. And I think that's perfectly fine there with that question, with these questions. And I hope you guys have learned a lot. This is very much important, and we will see each other in the next video, and I think it's perfectly fine there up until here, until we meet again. And thank you. Bye bye. See you on the next video.